Okay, now let's have a look at how we do our two basic operations, that's addition and subtraction with directed numbers. Now we've already had a look at how the pattern works, but we need to go beyond that. So here's the problem that we have. We start with a small number, say 5, and from that we're taking away a larger number, say 7. Now, we know that when we do 5 take away 5, we end up with 0. So if we're taking something greater than 5, from 5, we have to go past 0. And in this case, we know the difference between 5 and 7 is 2, but 7 take away 5 is 2. Hopefully you know that pretty well by now. So that's not what we have. We're not taking a smaller number away from a larger number. It's the other way around. So the result is negative 2. Now this is, for some people it's really easy to comprehend. For others it's not so easy. And the number line would assist in seeing what happens. So let's draw a number line. I'll just put arrows at the end of my number line. And let's mark in 0. Now I'm not going to be worried too much about being accurate. I've got a grid here, so I'm just going to count on the grid. 1, 2, 3, 4, 5. Here's my 5, and that's my starting point. Now I'm going to take away 7. If I took away say 1, well, that would take me back to 4. If I took away 2, that would take me back to 3. When from 5 I take away 5, that takes me back to 0. But from 5, I'm not taking away 5, I'm taking away 7. So that's remembering what 7 is made out of. It's made out of 5 plus 2 more. So that would take me down to negative 2. We have now gone beyond 0 to the negative side, to the left hand side of the 0. I hope that visual is helpful. Let's have a look at another question. Let's have a look at 3 take away 8. Now 8 take away 3, if you think about it, is 5. So the difference between 3 and 8 is 5, except I'm taking away a larger number from a small number. So I'm going again beyond 0. 3 take away 3 is 0, but I'm taking a lot more than that. I'm taking 5 more. So the answer is negative 5. Let's have another go at a number line. Put the arrows at the end of my number line, because a line continues in both directions forever. I'm going to mark in my 0. I'm going to count 1, 2, 3. That's my starting point. My starting number was 3. So I'm going to start at 3. And now I'm taking away 8. If I take away 3, let's try again. If I take away 3, from 3 I end up with 0. So once 3 is gone, how much more is left to make 8? 5. 1, 2, 3, 4, 5. And hopefully you can see that that leads to negative 5. So that's a visual representation. Now, a common mistake I've seen students make. I'm just going to erase that so I can use the same number line. Oh, I can't do that. Alright, let's draw a new number line. A really common mistake when students first learn about negative numbers. We are used to starting with 0, and I might start 0 there. And then we go 1, 2, 3, 4. So if I ask a student to draw a number line from, say, negative 4 to 4, for some reason they tend to do negative 4 here and -3 here, and -2 here. But if you look carefully, it doesn't quite make sense. 1 is bigger than 0, 2 is bigger than 1, 3 is bigger than 2. So as I move this way, the numbers are getting larger. Now let's look at the relationship between -2, -3, -4. Which one of those numbers bigger? Is -4 bigger than -3, or is -3 bigger than -4? That's an interesting question. A good way of representing that and talking about it is going back to temperature. We know 6 degrees is warmer than 5, is warmer than 4, is warmer than 3, warmer than 2, warmer than 1. 1 is warmer than 0. So the question is, if I have to choose between -1 and -4, which one out of these two is warmer? And hopefully you know that -1 below 0 degrees is warmer than -4. -4 is a lot colder. If you look on your fridge or freezer thermostat, you'll see that -4 is a cooler setting than -1, and 4 is a warmer setting. And that's the range usually for fridge freezer settings. So, having drawn an arrow saying as we go from left to right, numbers get larger, at the moment -2 is bigger than -3, and -3 is bigger than -4. So here I'm getting smaller, and that doesn't make sense. So that order is incorrect. From 0, when I go 1 to the left, I end up at -1, and when I move 1 to the left, I end up at -2. So 0 is at our center, and we go 1 by 1, getting smaller this way, and 1 by 1, getting larger to the right. So as I move to the left, we go smaller, and as I move to the right, we get larger numbers. And that makes sense even with our positives. As I move from left to right, these numbers are getting smaller. 4, 3, 2, 1, 0. So the same is true on either side of 0. The pattern must stay the same. Alright, let's look at another example of operations with directed numbers. So now let's look at an example where my starting number is not a positive but a negative. Say -7, and to that I add 4. What's that going to be? Well, I'm going to use a number line because I think having that visual in front of me makes life a lot easier. So I'm going to draw my number line. I'm going to mark in 0, and I'm going to mark in -7. Now let's see, 1, 2, 3, 4, 5, 6, 7. So let's mark in -7. Now I'm adding 4. Now if this was, say, 7 plus 4, you wouldn't have any problems with doing that question. 1, 2, 3, 4, 5, 6, 7. If that was 7 plus 4, you'd start from here and you go 4 that way. Well, I'm still going to do the same thing, except my starting point isn't 7, it's -7. But I'm still going to move 4 that way. And I end up here. So the process of plus, by adding, we already know when we add to something, we make it bigger. When I add to my height, I'm getting taller. When I add to my money, I'm ending up with more money. When I add to my weight, I'm getting bigger. So we already know that that's the process. So hopefully, we'll apply the same thing here. Negative 7 plus 4, that would be negative 6, negative 5, negative 4, negative 3. Following that, just to make sure, that's negative 2, that's negative 1, that's 0. And remember, think back to that temperature, negative 3 is a larger number to negative 7. So the answer is negative 3. I just want to point something out to you. What's the difference between 7 and 4? The difference between 7 and 4 is 3. So that's an indication of making sure we're doing the right thing. But between negative 7 and 4, that negative 7 had a bigger magnitude, but 4 was a bigger number. I think that might be a bit confusing. But negative 7 is bigger in size, but it's a negative. It's on the left-hand side. Anyway, I might have confused you with that comment. If you have gotten confused, ignore that. Alright, let's have a look at another example. Let's say I start with negative 10, and from that I'm going to take away 2. Now I want you to seriously think about it and draw yourself a mental number line. You don't have to have it on the page. I'll do it on the page, but you don't need to. Just in front of your eyes, imagine a number line, mark in 0, and try to have an idea of where negative 10 might be. Notice I'm not doing anything accurately anymore. Now, if that was 10 minus 2, on a number line, you'd start way out here as 10, or maybe even further, and then you take away 2. So that would, you know, that would be 8. So because it's take away 2, you're moving left. We're making things smaller. So if I'm starting at negative 10 and I'm taking away 2, I'm making things smaller. I'm moving 2 that way. So if I move 2 to the left of negative 10, that would result in negative 12. Let's keep going. Let's do one more example. Let's do something a little bit harder. Let's look at, remembering these are directed numbers, negative 10 minus negative 2. Now this is the trickiest we could have. So I now have 2 negative numbers. Let's draw a number line. Now teachers struggle to explain this, and I've got a way of explaining it. I'll explain it using a number line, and then I'll explain it using another trick. So just like before, we start with a negative 10. That's our starting point. And now I'm doing a takeaway. Well, great. Takeaway, we just talked about takeaway makes things smaller, so I need to move that way. But I'm not taking away 2. I am taking away negative 2. If I was taking away 2, I would move twice this way. But negative 2 is the opposite of 2. Think about where 2 sits. 2 sits on the right hand side, negative 2 sits on the left hand side. So if it's the opposite of 2, I need to do the opposite of what I would do with 2. So if I was taking away 2 and I would move left, I am going to have to do the opposite of that and move right. Now that is a bit confusing, I admit, and I'll explain it a different way. So moving 2 to the right from negative 10 is negative 8. I'm going to prove to you that that's correct. I'm going to prove it using a different method. The different method only helps in understanding how this works. You can't really do it every time you're trying to have a go at one of these questions. Okay, so we have negative 10 minus negative 2. I'm going to show you why that ends up being negative 8. Let's start with negative 10, take away 2. imagine a number line, negative 10, move 2 to the left, that would give me negative 12. Now I'm going to go negative 10 minus 1. Imagine a number line, start at negative 10, move to the left by 1, that would be negative 11. Now let's have a look at negative 10, take away 0. So we took away 2, we took away 1, we're taking away 0. And we know that if we take nothing away from a number, we end up with the number itself. So let's go to the next number, negative 10, take away what's one smaller. Let's just see the pattern. We're going from 2, taking away 2, taking away 1, taking away 0. So the pattern is every time we're taking away 1 less. So from 0, it's negative 1. What was the pattern on the other side? We went from negative 12 to negative 11 to negative 10. What do you think the next number is? Hopefully you said negative 9. And then from negative 10, if I take away negative 2, following the pattern, that would give me negative 8. So that's just to prove that what we just did is right. What we just did was to move twice to the right, even though it's at a minus, and we ended up with negative 8. Now that's quite amazing, because there's another operation you could do that would give you the same result. Negative 10 plus 2. Think of a number line. Let's do a quick one. Here's 0, here's negative 10. What do I do? Which way do I go for a plus? Plus makes things bigger. I move to the right 2. That would be negative 8. So what we've ended up with is when I took away a negative number, it behaved exactly the same as if I plussed. And I'm sure you've heard the statement, two wrongs don't make a right. Well, it's a very common thing that's said, because in mathematics, if I have two minus signs sitting right next to each other, no numbers in between, just like the one we just have above, then that behaves the same way as a plus. If I have two pluses sitting next to each other, now we haven't seen anything like that, that behaves the same as plus. But if I have a plus and a minus that are sitting right next to each other, that behaves as if it's a minus, and vice versa. Again, it behaves as if it's a minus. Now, some students struggle to memorize that. I'm going to tell you a trick. When people get along, it's because they like each other. And when they like each other, it's a plus, it's a positive, it's a good thing. So a minus and a minus, they like each other. A plus and a plus, they like each other. So that's a positive. But when people don't get along, they're too different, then that's a sad thing, that's a negative. So a plus and a minus are the opposites. They don't get along. What a shame, that's a negative. And then minus and a plus are a negative and a positive next to each other, result in a negative. So why do we do this? Because this makes life a lot easier. It makes the thinking, well, it means you don't really need to think as hard to be able to solve a problem. Let's have a look at an example. If I have 10 plus negative 4, well, I have a plus and a minus next to each other. So that behaves, they don't get along, that's a negative, that's a sad thing, so I replace it with a minus. And I know what 10 take away 4 is, hopefully, it's 6. If I have negative 6 minus positive 4, That negative 6, well, there's nothing, we talked about how two signs right next to each other, so the negative 6 is just negative 6, but I have a minus and a plus next to each other, and again they don't get along. That's a negative, so I have negative 6 take away 4, and hopefully by now you know that I start on my number line. Again, in your head, imagine a starting point of negative 6 to the left of the number line, on the left hand side of the number line, to the left of 0, and we're taking away 4. We're making it even smaller, moving to the left. That gives me negative 10. Hopefully that's clarified some of the ideas of how operations or addition and subtraction with number lines and directed numbers work. Time to do some exercises.